Hi all, welcome to Heights to 5. Today we are discussing about some examples of prime factorization, that is a fundamental theorem of arithmetic related problems, and it is examples are included in exercise 1.2 of NCERT CBSE 10th Standard textbook, exercise 1.2. The first question is, express each number as product of its prime factors. What is a prime number, what is a composite number, and what is fundamental theorem of arithmetic, all are discussed in the previous video. Today we are discussing some related problems. Here the first question is, express a number as product of its prime factors. Product of prime factors. First number mentioned is 140. We can factorize 140 if following this method by 270. How can we identify a number is a, I am giving a subdivision. We can identify a number is a factor of 2. That is 140. For number 142 is a factor. 2 become a factor of a number if it for satisfying condition. The last number should be 0, 1, 2, 4, 6, 8. If a number ends with 0, 1, 2, 4, 6, 8, we can say that that number contains 2 as a factor. For example, 76. The last number is 6. So we can surely say that 2 is a factor of 76. Next is number 3. Number 3 become a factor when the sum of digits of that number. Sum of digits of that number is 3, 6, 9. For example, 102. Here the sum of digits 1 plus 0 plus 2. 1 plus 0 plus 2 is equal to 3. 3. If the sum becomes 6, if the sum becomes 9, we can say that it is completely a factor. 3 is completely a factor of this value. Another example, 123. The sum is 5, 6. Sum is 6. So we can say that 3 is a factor of 123. Next, the value 4. We can say that a number has have 4 as a factor if it last 2 digits. The last 2 digits is a factor of it's a product of 4. For example, 4, 0, 4, 0, 8, 12, 16, 20, etc. If the last 2 digits, for example, 4804. Here the last 2 digits contain 04. Another case, 2616. The last 2 digits contains is a factor of 4. Another, and a special condition is also there. If the last 2 digits is 0 also, 2 digits are 0, we can say that. For example, 2600. The last 2 digits is 00, we can say that 4 is a factor of this number. Okay. The next case is 5. We can say that a number has 5 as a factor if it ends with either 5 or 0. Either 5, last digit either 5 or 0. For example, 105. Here the last digit is 5. So clearly we can say that 5 is a factor of 105. Another number, 230. The last digit is 0. So we can say that 5 is a factor of 230. Next, 6. 6, we can factorize 6x, 2 and 3. So the conditions for this satisfies for 6. The factor is a 6. You can factorize it is using 2 and 3. That number can factorize using 2 and 3. 7, there is no direct method. Next is 8. Similar, the last 2 digits, if a number is given, the last 2 digits should be a product of 8. For example, 8, 0, 8, 16, 24, 32, etc. And special condition is also there, 0, 0. Okay. For example, 4808, the last 2 digits it is 0, 0, 8. So it is a factor of, this number is contains 8 as a factor. 9, similar as the value of 3, that is sum of digits should be 9. Sum of digits should be 9. For example, 108. 1 plus 0 plus 8, which is equal to 9, which is factor of 108. Another 10. 10 becomes a factor if it ends with 0. 10, 100, 120, etc. Last digit 0. Next, 11. You can say that 11 is a factor. The alternate numbers sum, difference between the sum of alternate numbers results into 0. For example, 1, 3, 3, 1. Here the alternate numbers 1, 3, 3, 1. So sum is this 1 plus 3, 1 plus 3, which is equal to 4. 1 plus 3, this one, 4. The difference is 0. So the alternate numbers sum, have to take the sum of alternate numbers and before this take difference of these numbers. If the result is 0, we can say that this is a factor of 11. Okay, these are the methods. So how to find a number is a factor. 2 for 2, it ends in 0. 1, 2, 4, 6, 8. For 3, the sum of digits should be 3, 6, 9. 4, it is a factor of 4, 0, 4, 0, 8, 12, 16 and 20, either or 0, 0. 5, it should end with a 5 or 0. 6 is a factor of 2 and 3. Then 8 ends with 0, 8, 16, 24, 32, etc. or 0, 0. Last is 9. Sum of digits should be 9. 10 should end with a 0. 11, take sum of alternate numbers and the difference of this sum should be 0. In such case, we can say that 11 is a factor. Then go to the previous question, 140. Can factorize here 2. So 702, 35 ends with 5. So 5, 7. So we can say that 140 has prime factors 2 into 2 into 5 into 7. 140 is equal to 2 into 2 into 5 into 7. Next question. 156. 156, 2, 7, 8, 2, 3, 9. Here the sum is 12 and 3. So 3, 1, 3. It's a prime. 13 is a prime number. So we can represent 156 as 156 2 into 2 into 3 into 13. Next number 3825. 3825 divided by, the last number is 5. So 9, this one 6, 5, not 9, 7, 7, 32, 6. Okay. Next is 5 itself. 1, 5, 3. Next is 8, 9, 3, 5, 1, 3, 17. So the numbers are 5 into 5 into 3 into 3 into 17. Next goes to the next question. 5005 is equal to, factorize it. Here ends with 5. So 1, then not 5, 6, no other numbers. And we can divide it using 7, 30, 28, 31. Okay, 7, 1. We can divide through this. We can find 7, 30, 4, 28, 2, 1, 3, 143, 11. Alternate numbers 1 and the next number is 3. 1 plus 3, 4. 4 minus 4 is equal to 0. So we can say that 11 is a factor 13. When dividing 143 by 11, we get the result as 13, which is a prime number. 5 into 7 into 11 into 13. Next question. 7429. 7429 divided by 7429 11 2 3. Here the number is not a direct number, that is a previously discussed number. 12 13. When we divide 7429 by 13, it's not a factor. 17. There is no direct method to find out if 17 is a factor or not. We have to directly divide it. 7429 divided by 17, 4, 8, 2, 3, 51, 1, 1, 9, 7, 9, 0. So 17, 437, 17, it is 19. When we divide 437 divided by 19, we get 23. So 17 into 19 into 23. Here the factors are large values, so it is some bit difficult to find out the factors, but some logics can help to find out this value, because the last digit is 9. So we can think 13 into 13, like that. 17 into 7, 7 into 7, 9, ends with a 9. Such a logic will help to find out the factors. And the next question is, find the LCM and HCF of the pairs of integers and verify that LCM into HCF is equal to product of that numbers. Product of that numbers. Once again the question, find the LCM and HCF of the given numbers and verify that LCM into HCF is equal to product of that given numbers. Go to the first question, 26 and 91. When we factorize 26, we get the factors as 2 into 13 and 91, 7 into 13. 7 into 13. In previous video, we discussed about how to find LCM and HCF. LCM is the largest factors for both the numbers, and HCF is the smallest common factors. When we you find out the previous video, you can simply learn how to find LCM and HCF. LCM is equal to, here the factors are 2, another 13, here 13, another one 7. When you multiply it, the value is 182. HCF is equal to the smallest common factor. Here the common factor is only 13. 2 and 7 is not present in both numbers, so only 13. Then to verify LCM into HCF is equal to product, take the numbers 26 into 91, which is equal to 2366. LCM of 26 divided by 91 into HCF of 26 into 91 is equal to 182 into 13, which is equal to 2366. Hence, prove that LCM into HCF is equal to A into B. Next question or next numbers given 510 and 92. We can factorize 510 as 2 into 3 into 5 into 17 and 92 as 2 into 2 into 23. HCF is equal to smallest common factor. Here 2 square, here 2, so 2, 3 is not present in both cases. Only 510 has factor 3. Here 3 is not present, so we can't take 3, and 5 is also only present here. 17 also 23. So only the common factor is 2 and the smallest power is 2 raised to 1. So we take HCF as 2. LCM is equal to the largest factors. So 2 square into 5 into 3 into 17 into 23. 2's largest power 2 square. Here 2 and here 2 square. So we take the largest power 2 square into 5 into 3 into 17 into 23. All factors. Then A into B is equal to 510 into 92, which is equal to 46920. LCM into HCF is equal to 2 square into 60. 23460 into 2, which is equal to 46920. Hence, LCM into HCF is equal to A into B, proved. Another question, 336 and 52. 336 is equal to, the factors are 2 into 2 into 2 into 2 into 3 into 7. So 2 raised to 4 into 3 into 7. For 54, the values are 2 into 3 into 3 into 3, which is equal to 2 into 3 raised to 3. Here the value of HCF is equal to 2, the smallest power, 2 into 3, which is equal to 6. LCM is equal to 2 raised to 4 into largest power. 3 raised to 3 into 7, which is equal to 3024. So A into B is equal to, and we multiply 336 into 52, we get the value 18144. HCF into LCM is equal to 3024 into 6, which is equal to 18144. And the next question is 336 into 52. And the next question, go to the third question. Find the LCM and HCF for the following integers by applying prime factorization method. And the first question is 12, 15, 21. We can factorize 12 as 2 into 2 into 3, which is equal to 2 square into 3. 15 is equal to 3 into 5. 21 is equal to 3 into 7. So HCF is equal to the smallest power, 3. Smallest common power. LCM is equal to 2 square into 3 into 5 into 7, which is equal to 420. So our next question is 17, 23 and 29. 17, 23, 29. 17 is equal to 1 into 17. 23 is equal to 1 into 23. 29 is equal to 1 into 29. So there is, for finding HCF, there is no common factor, so we can say it as 1. LCM is equal to 17 into 23 into 29, which is equal to 11339. Next question, 8, 9 and 25. We can categorize 8 is equal to 2 raised to 3. 9 is equal to 3 square. 25 is equal to 5 square. So HCF is equal to, there is no common factor, so we can say it as 1. LCM is equal to 2 raised to 3 into 3 square into 5 square, which is equal to 8 into 9 into 25, which is equal to 1800. This question ends here. And the question is given that HCF of 306, 657 is equal to 9. Find LCM of 306, 657. This question is solved using our previously studied equation. A into B is equal to HCF of A comma B into LCM of A comma B. Given that HCF is also here A is equal to 306, B is equal to 657. So 306 into 657 is equal to HCF. HCF value given that HCF is equal to 9. So 9 into LCM. Then we can find out LCM. 306 into 657 divided by 9. I can divide it using 9, 3, 36, 4, 34 into this one, 2, 2, 3, 3, 8. 34 into 657 equal to 34 into equal to 22338. So LCM of 306, 657 is equal to 22338. And the next question is explain check whether 6 raised to n can end with the digit 0. A similar question was discussed in the previous video also. In that case 4 raised to n was there. Here 6 raised to n which can end with the digit 0. We have to check whether 6 raised to n can end with the digit 0 for any natural number n. Okay. If any number ends with the solution, if any number ends with the digit 0, it should be divisible by 10. If any number ends with the 0, it should be a multiple of 10, or it should be divisible by 10. That number should be divisible by 10. In other terms, we can specify it have factors 2 and 5. So this value should be 6 raised to n should be divisible by 2 and 5. Once again, if any number ends with 0, that number should be divisible by 10. 10 has factors 2 and 5, so that number should be divisible by 2 and 5 also. We can rewrite 6 raised to n as 2 into 3 the whole raised to n. Here 2 is included, but 5 is not present. 5 is not present. 5 is not in the prime factorization of 6 raised to n. So we can say that for any value of n, 6 raised to n will not be divisible by 5. Here it contains only 2. 5 is not a part of this number. So we can say that 6 raised to n will not be divisible by 5. So 6 raised to n cannot end with digit 0. Once again, question is check whether 6 raised to n can end with the digit 0 for any natural number n. If a number should be divisible by, if a number ends with 0, it should be divisible by 10. If a number is divisible by 10, 10 has factors 2 and 5. So it should be divisible by, or it should contain factors 2 and 5. But 6 raised to n contains 2 into 3 the whole raised to n. It has 2 as only the factor. So 5 is not in the prime factorization of 6 raised to n. So we can say that for any natural number, 6 raised to n will not be divisible by 5. So 6 raised to n cannot end with the digit 0. Next question. Next and last question. Last question is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into, select the question, 2 into 1 plus 5. Consider these two expressions. 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. The answer is simple. Are composite numbers. Explain why these two numbers are composite numbers. We can rewrite these expressions as the first expression 7 into 11 into 13 plus 13 as here two terms. Here, this is a single term, this is a single term. So we can take 13 as common element for easy to calculate. 7 into 11 into 1. This 13 is outside plus 1. Okay. Then we can rewrite 7 into 11 into 1 is equal to 77 plus 1, which is equal to 13 into 78. We can factorize 13 into 78 as 12, 14, 15, 6, 1, 3. 13 into 6. 13 into 6. This is the factors of this expression, and we have to go to the second expression, which is 7 into 6 into 5 into 4 into 3 into 2 into plus 5. Here this is a single expression. So we can take 5 as common, then the expression becomes, this 5 becomes 1 because we take the 5 outside. 2 into 1 plus 5 plus 1 plus 1. This one 5. When we multiply these two expressions, we get 5 here. Then 7 into 6 is equal to 42. 42 into 4 into 3 into 2 is equal to 1008 plus 1, which is equal to 5 into 1009. 1009, there is no other factors, 7, oh sorry, okay, it cannot be 5. This is also a prime number. 1009 is a prime number. Here we can say that the given expression has 6 and 13 as factors, so it is a composite number. This is a composite number. 13 and 6 are the factors. It has 13 and 6 as factors. Hence we can say that what? This is a composite number. Similarly, this expression has factors 5 and 1009, which is prime numbers. So we can say that this is a composite number. This is a composite number. This number has factors 5 and 1009. These are the factors. So we can say that this is a composite number. Once again the question. We have given two expressions which contains numbers. First expression we simplified it and expressed in the terms of prime numbers. So the first expression has 13 and 6 as factors. So we can say that the first expression is a composite number. Next, when we simplify the expression, we get the prime factors as 5 into 5 and 1009. So we can say that the expression is a composite number. So today we discussed problems on prime factorization, how to find LCM, how to find HCF, and the rules. HCF into LCM is equal to the product of two numbers. We proved that theorem. And finally, two proofs also. Thank you for watching. If any doubt, you have any doubt, please comment. And on next class, we discuss a new topic. Thank you. Thank you for watching. Subscribe and share for new videos.